Once again, we started a new lesson today, and we're moving on, and the lesson was similar figures. Our objective was I can identify and solve similar figures, okay? So from there, we needed to clarify the definition of similar figures. What are they? I gave you guys the definition. Similar figures are figures with the same shape but proportional dimensions. So let's find out what that means. Similar means, or similar figures are figures with the same shape but proportional dimensions. So, once I gave you examples, I gave you those. So let me go over these. Here it goes. So, what it means that they're proportional is that if they look about the same shape, look at these two triangles. Are they about the same shape? Yes, but one is larger than the other. So to find out if they are proportional, I'm going to choose two sides from one figure, and I'm going to choose the similar side from the other figure, set them as an equation, and see if they are proportional. Watch. Look up, please. So watch. I'm going to use this one, 15 and 25, and I'm going to write it as a fraction, 15 and 25. And those are similar to which values on this little triangle? 3 and 5. 3 and 5. So now, to find out if they are proportional, all we have to do is cross multiply. What is 3 times 25? 75. What is 15 times 5? 75. Is 75 equal to 75? Yes, that's why they're proportional. And if they are proportional, that means that this figure is similar to this figure. And what symbol am I going to use for that? I'm going to use this symbol. Look up. The little wiggle. So this triangle is similar to this triangle. Does everybody understand? So, I'm going to check this one right here. Let's see. What would be my fraction for this one? 5 over 8. I'm going to write over here 5 over 8 equal to 12.5 over 20. Okay, so let's see. Let's cross multiply. What is 5 times 20? 100. So let's see. What is 8 times 12.5? Let's see. 12.5 times 8. 0, I got 4. 16 plus 4, that's 20. 8, that's 10. 1 decimal place. It is 100. So what are these? They are proportional. So if they are proportional, that means that this one is what? Similar to that one. We're not saying equal. We're saying that they are what? Similar. Everybody with me? Okay. So, above or underneath this term similar, I want you to put the little symbol that we use. Similar. Yes. No. 100 is equal to 100, isn't it? They're not similar, they're equal. This figure is similar to this one. It's not equal because it's not the same size, right? But it's proportional. Alright, so now that we got that, let's find out what are non-examples. Here he goes. Copy this one down, please. Let's say this one is 10, this one is 20, this one is 5, and this one is 5. Alright, so let's see. Even they look kind of the same, but let's find out if they are proportional. What do I write for this one so I can check? 10 over 20, and this one is 5 over 5. Let's see. Cross multiply. This is 50, and this is 100. Is 50 equal to 100? No, so you put a dash to it because it's not equal. So therefore, look what I'm going to do here. I'm going to write again the symbol for similar, but I'm going to put a dash like this, saying that it's not similar. Does everybody understand what we're doing? All right. So similar figures are figures that are proportional, number one, and number two, that they have what? The same shape. So here it's same shape, and they are proportional. That's the most important thing to remember about similar figures. Copy that, please. All right, here we go. Copy these steps, please. Steps. Right underneath that. To identify and solve similar figures, number one, identify the similar figures. Number two, write a proportion and solve. Number three, simplify to lowest terms. It's only 3 steps. Copy that. So, steps. Step 1, identify similar figures. Step 2, write a proportion and solve. Step 3, simplify to lowest terms. Step 1, identify the similar figures. Step 2, write a proportion and solve. Step 3, simplify to lowest terms. Step 1, identify the similar figures. Step 2, write a proportion and solve. Step 3, simplify to lowest term. Step 1, identify the similar figures. Step 2, write a proportion and solve. Step 3, simplify to lowest term. All right, so we got it, right? All right, in the back of the paper, copy this example down, please. Example 1. If you still have room, yeah, copy it in the back. Here we go. Example 1, which rectangles are similar? Rectangle J has measurements 10 centimeters and 4 centimeters. Rectangle K has 5 centimeters and 2 centimeters. Rectangle L is 12 centimeters and 5 centimeters. Copy that, please, and we're going to do this one together. Go. Oh, my bad. So we tested K and L. These were not proportional. So therefore, we created our proportion with J and K. So that was 10 over 4, 5 over 2, cross multiply, 20 equal to 20. So what did we find out? These two are similar. So this is similar to K, and we write it as rectangle J, similar to rectangle K. Everybody got it? Yeah. All right, do this next one by yourself. Example 2. Example 2. Copy this one. So for example 2, we have rectangles A, B, and C. Thank you. Example 2, and it says, which rectangles are similar? Rectangle A is measurements 8 feet and 4 feet. Rectangle B is 6 feet and 3 feet. Rectangle C is 5 feet and 2 feet. Go. All right, let's see. Let me get the randomizer. How about Andrew? What'd you get for number 2? Rectangle A is similar to rectangle B. Hands if you got that? That is correct. Let's find out why. Let's create a proportion with this. 8 over 4 equals 6 over 3. Cross multiply. This is 24. 8 times 3, 24. And that is true, so that's why they are similar. Go to the next one. Example, let's label this one example 3. I don't know why I'm behind count. Example 3. Copy this one, please. No, just the black text. It says, a picture 10 inches tall with 14 inches wide is to be scaled to 1.5 inches tall to be displayed on the web page. How wide should the picture be on the web page for the two pictures to be similar? Copy that, please. All right, here we go. So that we can get the picture. See what I did right there? Yeah. All right. So, because it says a picture 10 inches tall and 14 inches wide is to be scaled 1.5 inches tall to be displayed on the web page. How wide should the picture be on the web page for the two pictures to be similar? So that you can get the picture. See what I did there? Okay. All right, check this out. Let's draw first a big rectangle here. That's going to indicate that that's our big picture. So that one, let's see, how tall is it? 10? Oh, hold on. Let me fix this a little bit. There you go. Like that. 10 inches tall. Label that. And 14 inches wide. All right? That's the original picture. So, from there, we're going to draw the picture that's going to be on the web page. It has to be way smaller than that, right? So I'm going to draw it over here. There it is. And it says, is to be scaled 1.5 inches tall. So this is 1.5. This is 1.5 inches. Do they give us the width? No. So we're going to label this what? X. So this is how we can solve to make sure it's proportional. We're going to create a fraction for this one. So this is 14 over 10 equals, what do we write? X over 1.5. And at that point, notice that this is very similar to what we did on the warm-up. Cross multiply. I always start with the variable. X times 10, that is 10x, equals 14 times 1.5, that's 21. And then at the end we divide by 10, x equals 2.1. So the width is 2.1 inches. 2.1 inches. So let's write our statement. The width of the picture on the web page is 2.1 inches. 10Q. Okay, copy this next one, please. Example 4. Example 4. It says, a painting 40 inches long and 56 inches wide is to be scaled to a 10-inch long to be displayed on the poster. How wide should the painting on the poster for the two pictures be in order for the two how wide should the painting be on the poster for the two pictures to be similar? Copy that and solve that one by yourself. We already did one together. Go. Hands if you got x equals 14. That is correct, but what is your statement? Remember, you need to write a sentence at the end. Yes. The width of the painting. The other poster was 14 what? Inches. That is correct. So x equals 14 inches. All right, let's move on. Copy this next one down, please. Example number 5. Example 5. Copy this one. Example 5. It says, the t-shirt design includes an isosceles triangle with side lengths 4.5, 4.5, and 6 inches. So for those of you that forgot, isosceles triangles are triangles that two of their sides are the same measurement. So therefore, an advertisement shows an enlarged version of the triangle with the two sides that are 3 feet. 3 feet long. What is the length of the third side of that triangle in the advertisement? Copy that, please. As you're copying that, I'm going to draw my isosceles triangle so you can get an idea of what we're looking at. There it is. So this one is the triangle on the shirt, and this is a triangle on the advertisement. It's way bigger, right?
Yeah.
So the sides, these are 4.5 inches, 4.5 inches, and the length is, or the base is 6 inches. So the new isosceles is 3 feet, 3 feet. So which is the only side that we're missing? The bottom one. So let's make a proportion. So what do I write for this one? 4.5 over 6 equals over x. And you know how to solve this, right? So your home play for tonight is found on pages 240, 241. Have a good one, everyone. Enjoy your home play. See you guys always. Bye.